My name is Fred, and in this second video on statistics I'll show you how to use the calculator. So I'll mark all the data we have got on the red girls that we also used in the former video 8. And now I'll simply use one variable analysis. Please analyze these, and here they are. I could have it as a histogram. I could have it as a box plot. I could have all the figures for the mean value, for the minimum, maximum, median, the first quarter, etc., etc. Problem with this is if you do it in front of the students, they might feel that it's too much in one go. That's one problem. The other problem is you cannot compare as I did in the former video. But there is this possibility of making all the computations in one go. Close down, don't save. And here I have another example, and here the calculator comes in very useful. But at first in the spreadsheet here I have done it without a calculator. I assume that these four data are registered in some way or another. It is about whether or not if parents smoke in a home, the child will smoke or not. So, certified children, they smoke and their parents smoke. 23 children don't smoke even though their parents smoke. If their parents don't smoke, there are still 33 children smoking and 46 homes with no smokers at all. Altogether 137. There are 68 smokers among the children. There are 69 non-smokers among the children and by the parents. There are 58 homes where the parents smoke and 79 homes where the parents don't smoke. Now we can make some expected values if we assume independence. So among the 68 here, we will take the 68 and we'll take 58 divided by 137 times 68. So 28.79. You see how it is computed here. This is what we expect if there are no dependency, if they are independent. And the same way the other figures here are computed. If the children don't smoke, there are among the 69, we expect that 58 divided by 137 will not smoke. And we can see it here, how it's made. So it is the 58 divided by 137 times the 69. When we evaluate the chi-square test, we have to make some chi-square values. And the first one here, that is the difference between those two divided by the squared divided by the expected. So we have difference between that one, 23, and what was it? Well, fortunately I haven't bound here. 23. So I'll show you. It's the difference between C5 here, the 35, and the expected 28.79 squared divided by the 28.79, and you get this value. You add the four values together and you get 4.61. The degrees of freedom here is 1, and you get the chi-square value, it's 461. If you look it up in a table, you see that the probability here is 3.17. That is it is very unlikely that this would happen if we randomly went out to 137 homes. There's only a probability of 3% that this would happen. So we must say that the independence, what we assumed here, is not true. They are very much dependent. I've made some other figures here to try with, and I'll try to make those 4. So I will copy them and put them up here. And these numbers are very much alike, and you see that you get a very small figure and very high probability here. And otherwise, these are very unlikely. I take these 4, copy them, move up and put them into the spreadsheet. And these are very, very unlikely. It's very unlikely this would happen. Now I'll go back to the first figures. And I'll put them back, because now I'll use the possibility of computing these data. So I'll go to the probability calculator, and I've already chosen the chi-squared test, and I've already chosen 2 rows and 2 columns. Now I'll put the data in. Unfortunately, you cannot just copy them. 3, 5 for that one, and 3, 3 for that one, and 2, 3, and 4, 6. It immediately copies the results here, and I can see that fortunately I get the same figures as I got before. Probability being 3.17. Degrees of freedom being 1, as there are 2 columns and 2 rows. So it's 2 minus 1 times 2 minus 1, it is 1 for the degrees of freedom. And this ends the video number 2 on statistics.